In question 8, the function f is defined by f of x equals to 2 minus 3 upon 4x minus p, where p is a constant. In part A, we have to find f dash of x, which basically means the derivative of f of x, and then hence we determine whether f is an increasing function, a decreasing function, or neither. In the first step, before differentiating, we'll bring the 4x minus p in the numerator. So this will become 2 minus 3 into 4x minus p to the power minus 1. Differentiating f of x, so the derivative of 2 is 0. Minus 1 into minus 3 will become a plus 3 into 4x minus p. The power will decrease by 1 to make it a minus 2. And we also multiplied by the derivative of 4x minus p, which is 4. Simplifying this will become 12 upon 4x minus p whole squared. Now, as we have positive 12 in the numerator and 4x minus p whole squared, it will always be positive for all the values of x. So it will write it as 4x minus p is 4x minus p whole squared is always positive for all values of x. This means that f dash of x will be an increasing function as it will always be greater than 0. In part B, we have to express f inverse of x in the form p upon a minus b upon cx minus d. So f of x was given as 2 minus 3. So this was 2 minus 3 upon 4x minus p. To find inverse, first we write y in place of f of x. So this will be y equals to 2 minus 3 upon 4x minus p. Now exchanging the values of x and y, this will become x equals to 2 minus 3 upon 4y minus p. Now to bring it into this particular form, we can first bring the 3 upon 4y minus p on the other side. So this will become 3 upon 4y minus p, and this will be is equals to 2 minus x. Now, as the form said b upon cx minus d, so we'll bring the 2 minus x in the denominator of 3 and bring 4y minus p on the other side. So we can write this as 4y minus p will be equals to 3 upon 2 minus x. Now to make y the subject, first we'll bring the p on the other side. This will become p plus 3 upon 2 minus x. In the last step, we'll divide it by 4. So this will become p upon 4 plus 3 upon 4 into 2 minus x, as 4 will divide with both the denominators. So this is 4 into 2 minus x. Now, as the expression was p upon a minus b upon cx minus d, so as we have a plus sign over here, we can bring a minus by first expanding this. So this will become 3 upon 8 minus 4x. So let's say if I take negative common out from over here, we can write this as y equals to p upon 4. So as we took the negative out, we can write this as, in the first step, we can just write 3 upon, taking negative common out, this will become 4x minus 8, and then we can write the negative sign up here. So the final expression will be f inverse of x will be equals to p upon 4 minus 3 upon 4x minus 8. In part C, it is asking, hence state the value of p for which f inverse of x is basically identical to f of x. Now f of x was, if you look at the expression f of x, it was 2 minus 3 upon 4x minus p. Now, in place of p over here, we have an 8. So if I put an 8 up here, 8 upon 4 will become a 2. So we'll say that for p equals to 8, f inverse of x will be identical or an identity of f of x.